Hi, Algebra 1. In lessons 12 and 13 here, we're going to be writing and graphing systems of linear equations. So that means more than one equation at a time. Here we go. All right, before we get going in this, here's your warm-up. Given this information in these three things, decide if each of these four combinations are a possibility for Diego. One way you could solve this is to write an equation and then substitute in your numbers for raisins and walnuts and see if it is indeed a solution. When you do this, the only one that ends up being a solution is this third one right here. If you put in 2.25 for R and 0.75 for W, it would end up equaling $15. Okay, in trail mix, the next activity, we're going to be looking again at Diego and his trail mix. So in A, we're writing an equation to represent this situation. So X is going to be the pounds of raisins and Y is going to be the pounds of walnuts it tells us to use. And so if raisins are $4 a pound, that's going to be 4 times X, and walnuts are $8 a pound, that's going to be 8 times W equals $15. And we want to figure out all these possible combinations that could get us to $15. Here I've graphed our equation in Desmos and zoomed in a little bit. Remember, X is our raisins, Y is our walnuts. And so every combination that's along this line, when you put your finger and you drag it along that line, those are all combinations that'll get us to $15. So if we have to start out with 0 pounds of raisins, we would need 1.875 pounds of walnuts. And I can see that on my graph. Also, if I plugged in 0 for X and 1.875 for Y, I would get to 15. Now looking at my graph, if I had 0.25 pounds of raisins, I can find that I would need 1.75 pounds of walnuts. And I can see from my graph that if I have 1.37 pounds of 3.75 pounds of walnuts, I would need exactly 1 pound of raisins. And sometimes it's hard to get exactly on that point, so zoom in and zoom out on your graph as you need. Fill in the rest of your table and check back when you're ready. And here's the rest of your table filled in. Now remember, if you plug these in for X and Y, they would be solutions. They would make this equation true. And I just realized that this should be a 8y equals 15. Also, if you graphed these as coordinate pairs, they would all fall right on that red line. Now with Diego, we're going to talk about what's going to happen if he buys 2 pounds of raisins and walnuts combined. So X is still going to be the pounds of raisins, Y is still going to be the pounds of walnuts, but we're not going to worry about how much he's spending. We just want to know what are the possible combinations that could get us to 2 pounds. So for example, if he has 0 pounds of raisins, that would mean you have to have 2 pounds of walnuts to have 2 total pounds. If he has 0.25 pounds of raisins, that means he needs 1.75 pounds of walnuts to have them add up to 2 pounds. Here's your completed table. Here's what it would look like when you graph it. And again, on my graph, I can use my finger and find out where those values are. Now, sometimes it doesn't end up to be exact, so you might have to try zooming in or zooming out to get those exact values. Then this last value right here, if he has 3 pounds of raisins, that means we would need -1 pounds of walnuts, which is not possible. So in this situation, this is not a possible combination. Now we're looking at number 3 in the trail mix problem, and it's saying that Diego spent exactly $15, so that's this equation, and he bought exactly 2 pounds of raisins and walnuts, so that's this equation. So how many pounds of each did he buy? So these were those 2 tables that you just filled out. And what I'm noticing is that this combination right here is the combination that gets him exactly $15 and exactly 2 pounds, and you'll see that solution on this table as well. And you'll notice that if you graph both of the equations we've been working with at the same time, that point that we've been looking for is right there. 0.25 pounds of raisins, 1.75 pounds of walnuts gets you both $15 and 2 pounds of stuff. So this is what we would call a system of equations, when there's 2 equations that we're looking at the same time, and we're looking for that one solution that makes both of the equations true. Now we have a few examples on how to write the equations for these systems. So this first one is looking at long and round tables. Long tables is going to be the X, round tables is going to be the Y. It says that we have a total of 25 tables, so X plus Y is going to equal 25. we don't know how many of each we have yet. Long tables can seat 8 people, and round tables can seat 6 people. And on a busy evening, all 190 seats are occupied. So long tables were X, so they can seat 8 people each. Y is the number of round tables, they can seat 6 people each, and we have a total of 190 seats. So again, this is called our system of equations. And when I graph both of those equations in Desmos, that point where they cross right here is going to be the point that gives me the combination that I need. So in this case, it would be 20 is our X, that was our long tables, and 5 was our Y, and that's going to be the round tables. So if I have 20 long tables and 5 round tables, I'll have a total of 25 tables and a total of 190 seats. Here's your system of equations for this one. This big curly bracket is what we usually use for systems of equations. It's not absolutely necessary though. Desmos can only use X and Y, so for A I used X and for C I used Y. And when we're looking on our graph, this point where they cross right there is our solution. So that means that A is 7 and C is 9. So that means 7 adult tickets and 9 children tickets is what they bought to have a total of 16 tickets and spend a total of $141. These make both equations true. In this one, I used X for my L and Y for my S when I graphed it in Desmos, and the point where they cross is right here. Now what this means is that a large poster costs $4.95 and a small poster costs $2.30. Toward the end of your lesson summary for lesson 12 here, there's 2 things that are important. A system of equations is what this is right here. It's 2 or more equations that we need to solve at the same time. And the solution is going to be the pair of values that makes all of the equations in the system true. So a value for X and a value for Y.